Hey kids, this is Mr. Marenko. So in the last video, we were talking about the project that we're going to be doing. Now, at this point, you should be working on the project a little bit. You should be making some headway, and then you should be like thinking about how can I make some triangles congruent. So this video is going to be a little bit more technical. It's going to be a little fast, but it's going to be a little technical. And this video, we're going to talk about triangle congruence theorems, because there's only so many ways that you can prove that triangles are congruent. Okay, so triangle congruence theorems. And we're going to be talking about a few of them. We're going to be talking about some that would seem like they work, but they really don't. Okay, so here's the first one. And I'm just going to be breezing through this. There's stuff in your book that explains it a little bit further, but honestly, I don't know. Unless you really, really want to get into it, just understanding what they are and how they work is kind of enough. So for each one, we're going to look at an example, and we're going to look at what it looks like in a proof, because your IXL work is going to be filling in parts of proofs. All right, so we're going to look at what a proof looks like with each one of the theorems. All right, here we go. First one, it's SSS. It means side, side, side. A triangle congruence theorem. So if three sides of a triangle are congruent to three sides of another triangle, then the triangles are congruent. Seems very straightforward. So if I have two triangles, boom, this one's the same as that one the same as that one, that one's the same as that one, they're the same. Seems very straightforward. Now, here's what it looks like in a proof. And sometimes there are these hidden things that you kind of don't see in the beginning, and you're like, oh, okay. It's not until you've seen an example of it that it really comes into play. Like here, we are given, so we're given that TI is congruent to TO. We're also given that IK is congruent to OK. And what we need to prove is that, triangle TIK, TIK, is congruent to triangle TOK. Yeah, I did that. I went there. All right, so here's what the proof is going to look like. Okay, here we go. So we got our two columns. Remember, two columns, one is for statements and one is for reasons. And so lots of proofs that you're going to see are two-column proofs. Here we go. So first we start about with all the given stuff. Okay, so TI is congruent to TO. So TI is congruent to TO. And IK is congruent to OK. And that's all given. We just put it all in one line. Now, here's what's hidden. We have two sides, but we know that we have to use side, side, side. So somehow we need to get this third side of each triangle in our proof to show that the third side of this top triangle is congruent to the third side of that bottom triangle. Luckily for us, it's the exact same line. And so we can say TK is congruent to TK, and this has to do, or we can say this because of one of those properties that we talked about last week, and that is the reflexive property. Of congruence. Everything is congruent to itself. So TK is congruent to TK. We can mark that. Notice the one tick mark, those are congruent. Two tick marks, those are congruent. Three tick marks, it's congruent to itself. So now we have one side, we have two sides, we have three sides. We can go straight up. Triangle TIK is congruent to triangle TOK because of side, side, side. And that's all you really need to write is side, side, side. Okay? So that's what it looks like in a proof. Usually you're given some stuff. You have to identify either the third side or the third part of the triangle in order to get the triangles to be congruent. Okay? So that's side, side, side. Another one that we have is side angle side. And side angle side means if I have two triangles, two sides are the same. So this side is congruent to that side. This side is congruent to that side. Then the included angle, we talked about that, what that means in the last video. The included angle of each one is congruent to the other. Okay? Now the triangles are congruent. Reason being is that if I have a certain angle, I go out a certain distance this way, a certain distance that way, there's literally only one line that can fit between the two endpoints. Okay, so that means since these angles are the same, these sides are automatically the same, and you go back to side, side, side. That's kind of the quick and hand-wavy way of showing why side angle side really works. Okay? But here's what it looks like in a proof. Okay, so we are given, now here there's nothing marked, but I'm going to tell you that A is the midpoint of DT and MC. And so we're given that, and we need to prove that triangle MAD is congruent to triangle CAT. Okay? So here we go. Let's get our two-column proof. Make our two columns. Let's start with the stuff that we're given, because we always start with the stuff that we're given. So A is the midpoint of DT and MC, and that's given. Well, what does that mean? What does that mean? That means that DA is congruent to AT, and it also means that MA is congruent to AC. And you might be asking yourself, well, why? Again, we talked about this before. When you have the midpoint, it's the point exactly in the middle, which means that each of these sides is the same length. So that side is the same as that side, and this length is the same as this length. So we can call them out as being the same length, and that's just what it means to be a midpoint. So that's definition of midpoint. Definition of midpoint is what it means to be a midpoint. Now, here's one little thing that you may or may not know, is that this angle is actually congruent to this angle on this side. And the reason being is that this angle and this angle, they share a vertex, and each of the lines that make up the angle are the same. So we call these vertical angles. Call those vertical angles, and vertical angles happen to be congruent. Imagine if you have two chopsticks, okay, or if you have two pens and you cross them like this. No matter which way you turn or bend, you can't really bend the pens. Since these are straight lines, think about the angle on top and the angle on the bottom. They're always going to be the same. No matter which way you go with the pens or the chopsticks, those angles are always going to be the same. And those are called vertical angles. So we can say that angle MAD is congruent to angle CAT because vertical angles are congruent. Okay, so vertical angles are congruent. So now we have two sides that are congruent and the included angle, which means now we can say that triangle MAD is congruent to triangle CAT because of side, angle, side. Side, angle, side. And you kind of go in order. Side, angle, side, side, angle, side. Okay, so the corresponding sides and angles have to be congruent. All right, so that was side, side, side. Now side, angle, side. Next one is going to be angle, side, angle. Okay, angle, side, angle. So here's what we have. We have two angles. So this angle is the same as that angle. They're congruent. This angle is congruent to that angle. And then the included side, remember we talked about that in the last video, included sides are congruent as well. That makes these two triangles congruent. Okay? Reason being is that if you have these angles and they're a certain distance apart, they're always going to meet up in the same point if you extend their rays. Always going to meet up in the same point, which means that this side will be congruent to that side. This side will be congruent to that side. And it goes back to side, 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 side. They all kind of come back to side, side, side. These are all just different ways of getting there. Okay. All right. So here's what it looks like in a proof. Now what we're given is that HIPO is a parallelogram. Because of the picture, we're also given that angle H or angle IHP, is congruent. So IHP is congruent to OPH, angle OPH. And also from the picture, because they're marked, if they're not marked, then you can't use it. Only if they're marked, that PHO which is one of my favorite foods, is congruent to angle HPI. Okay? And we need to now prove that triangle HIP is congruent to triangle, yeah, I know you thought that I was going to go HOP, huh? Yeah, no. I have to go triangle POH. You thought that I was going to go with hip hop. I know you. Okay, here we go. Two columns. Let's start with the stuff that's given. And actually, I'm not even going to worry about the HIPO as a parallelogram. We don't always have to write down everything that's given. If this doesn't serve us, then we don't need it. We don't need to write it in our proof. If we didn't have these, then this would tell us a lot about these, but we don't have to worry about it. In fact, if we didn't have these, we could still prove that they're true because of something called alternate interior angles. If we have parallel lines that are cut by what's called a transversal, a line that connects them to, the alternate interior angles are congruent. And alternate means they're on the opposite side of the transversal. Interior means that they're inside of the lines and they're angles. Okay? But that's a different video. That's a lesson for another day. So here, angle IHP is congruent to angle OPH and angle PHO is congruent to angle HPI. That's all given. Now again, we see that there's a line that is common to both triangles. So we can call that out if we need to, and in fact we do need to. So we can say that HP is congruent to itself because of the reflexive property of congruence. Okay, everything is congruent to itself. So now we have an angle, a side, and an angle. The side is included. So now we can say triangle HIP is congruent to triangle POH because of angle, side, angle. Okay? So those are the major three, the big three: side, 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 side angle, side, and angle, side, angle. Those are the three main triangle congruence theorems. And at this point, you might be thinking to yourself, you know what? I could just take any of those S's and A's and just throw them in any order. In fact, I can make a bad word out of it. So some of you are thinking, oh, hey, look, I can go angle, side, side. Oh my goodness, I'm so clever. Angle, side, side does not work most of the time. Most of the time. There's one exception to that rule. And that exception is what we call hypotenuse leg. So we take angle, side, side, and we're like, you know what? Let's use it sometimes, but only if we have a right triangle, or two right triangles, in fact. If you have two right triangles, we can say, okay, you get the angle here, and then a side, and then another side. So angle, side, side kind of works in this case, but we call it hypotenuse leg because we don't want to be dirty. So hypotenuse leg, here's why it works. You know that there is something called the Pythagorean theorem. And so if this side is congruent to that side, this side is congruent to that side, do the Pythagorean theorem, automatically this third side will be congruent to that third side. Boom, side, side, side. Again, these are all ways to get back to side, side, side. Okay? So hypotenuse leg. And here's what it would look like in a proof. Okay? So we're given that angle MHA and angle THA, so the measure of angle MHA equals 90 degrees. The measure of angle THA equals 90 degrees. So we know that they're right angles, which gives us right triangles. And we also know that MA is congruent to TA. And we want to prove that triangle HAM is congruent to triangle HAT. Okay. So let's go ahead and make our two columns. This one's going to be a little bit more involved because we're starting off with angle measures instead of congruent angles. So we're going to start with everything that we're given. So the measure of angle MHA equals 90 degrees. Measure of angle THA equals 90 degrees. And MA congruent to TA. And that's all given. Now, because these two have the same angle measure, that means that they are congruent. So since measure of angle MHA is the same as the measure of angle THA, then we can say that angle MHA is congruent to angle THA, and that is definition of congruent angles. Okay, so that's what it means to be congruent, that they have the same angle measure. Now again, we have MA and TA, but we also have this one. Again, we have more reflexive property. So that means we can say that HA is congruent to HA. And you might be laughing about that. Ha ha. But it's true. Reflexive of congruence. Reflexive property of congruence. All right, so we now have right triangles. We have a hypotenuse that is congruent to the other hypotenuse. And we have a leg that is congruent to the leg in the other triangle. So now we can say that triangle HAM is congruent to triangle HAT. And that is because of hypotenuse leg. Now this one is not in the book. At least I don't think so. I don't remember seeing it in the book. But this is an extra one that is very important, okay, because we're not allowed to have the other thing. No donkeys. Okay? Now, the next one that you may be wondering, it's okay, well, what if I can have side, side, side? I can have all these combinations. But what if I had angle, angle, angle? You would think, right, that maybe it would work. But it doesn't. Now, AAA, angle, 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 that'll give you some similarity, but it will not give you congruence. Here's why. Here I have two triangles, and this triangle, as you can see, they can see that they are not congruent because they don't have the same sides. Okay, so this side is not congruent to any of these sides. So since we don't satisfy side, 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 we cannot possibly have congruent triangles. However, if I were to take this and move it over, that angle matches up perfectly. And if I move it down, this angle matches up perfectly. And if I move it over, this angle matches up perfectly. So by angle, 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 if angle, angle, angle were a thing, then these would be congruent, but we already know that they're not because they don't satisfy side, side, side. Okay, so that means that angle, angle, angle does not work. Okay, so angle, 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 not congruent. Okay, it'll be similar, not congruent. This one is just bigger than that one. It's maybe a 1.5 times bigger or something. Okay, so all the angles are the same, but the sides are not. All right, so that was super quick. Hopefully you got them all. Remember, the ones that you're going to have to remember are side, 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 congruence theorem, side, angle, side, angle, side, angle. Those are the major ones. These are the ones that you're really going to have to focus on. And then in a pinch, if you have some right triangles, then you can use hypotenuse leg, which is really angle, side, side, but we don't say that out loud. All right, so those are your congruence theorems. You're going to use these when you're doing your write-up for the project. So make sure you're good with these and make sure you can write them up and use them to prove your case, because this is going to be that argument, that mathematical stuff that you're going to need. All right. All right, kids, that's it. Remember, do the IXL work. Your Google form is going to act as your quiz. And don't forget to come and see me on Thursdays.